Well, there's two approaches. One, hold on a second. Ooh, what is that noise? Wow, that's not a bad circle. That might be the best circle I've ever drawn. One approach is to memorize all 16 slices of the unit circle. This being 30, this being 45, and this being 60. And memorize these coordinates. That's kind of what they want you to do in the Colorado school system. Personally, I think that sucks. I think there's a far better way to memorize the unit circle. And it involves memorizing groups of 3 or 4 things. In other words, I do agree that you need to memorize the first quadrant of the unit circle. You need to know what sine of 30 is, sine of 45 is, sine of 60, sine of 90. However, when it gets to the other quadrants, when you're talking about the sine of 120 degrees or the tangent of 225 degrees, there are better ways to memorize that. And so let's go over them. Oops, started in the wrong quadrant. If you memorize what I have on the page right now, as long as you know the first quadrant, ratios, trig functions, you can convert. Okay, and the only thing you really need to know to memorize first quadrant are these 2 basic triangles that you've been working with for 3 years. The 30, 60, 90 and the 45, 45. I think this is by far the easiest way to learn trig. Everything you see on the page right now allows you to create the unit circle with the exception of the quadrangles, the 90 degrees, 180, and 270. But any other angle, if I said to you, what is the tangent of 225? Well, which quadrant is that in?
Quadrant 3.
Okay, so which formula applies? That one right there. So plug in 225 for theta. What do you get? What this gives you is the equivalent first quadrant angle. In other words, if you plug in 225 for theta, then you're really talking about the tangent of 45 degrees, which we know to be 1. And then all we have to do is put a sign on it, a plus or minus sign. Well, this tells us that it's plus in the third quadrant. So the tangent of 225 is plus 1. And that's the way I do it, and that's the way I can recreate the full unit circle no matter what angle, as long as it's a multiple of 30, 45, 60, or 90.
Wait, I'm a little confused how you got the plus 1 part.
Okay. First of all, I do it in 2 steps. I find what is the equivalent first quadrant angle. Well, based on this formula, that would be 45 degrees. Tangent of 45 degrees is 1. However, the tangent of 225 degrees, we have to figure out, well, what's the sign going to be on that, the plus or minus sign? Well, in the third quadrant, tangent is positive. So that's how I get the plus 1, is that the number is always the same as the equivalent first quadrant angle. The sign on it, and by sign I mean plus or minus sign, is always whatever all students take calculus dictates. Since t is tangent in the third, the tangent is what's positive in the third. Okay, so let's do another one. Let's do the sine of 210. Work that out for me. What's the sine of 210 going to be? It's the equivalent. When I say equivalent, what is the equivalent first quadrant angle for 210?
It would be 210 minus 180.
Okay.
Equals 30 degrees.
Okay, what is the sine of 30? Looking at this triangle over here.
Is it the opposite? Is that? Oh.
What is the sine of 30 degrees?
The square root of 3 over 2.
No. Opposite is 1. Hypotenuse is 2. So it's 1/2 is the sine of 30 degrees. But what the sine of 210 degrees, that's in the third quadrant. So it's going to be 1/2, but what's the plus or minus sign going to be on it?
It would be negative?
Yes. The sign is negative in the third quadrant because only tangent and cotangent is positive. Every other trig function is negative. So that's the way I do it, is I figure out the value first, the absolute value, and then I just throw a sign on it. And that way, the only thing you really have to memorize are these first quadrant angles. And you don't even have to memorize those if you know these 2 triangles. In other words, these 2 triangles will give you 30, 45, and 60 for all 6 trig functions. Now, let's talk about the quadrangles for a minute. There are 2 different ways to memorize what the quadrangles are. The one that I like the best is memorizing the sine and cosine curves. This is the sine curve. And memorizing all the quarter points. It doesn't matter whether you label this in radians or degrees. That's the sine curve. This is the cosine curve. Now these quarter points are important because that's where all the important stuff happens. In other words, if you look at the sine curve, sine of 0 is 0. But it becomes 1, its maximum, at pi over 2, or 90 degrees. comes back to 0 at pi, goes down to its minimum at 3 pi over 2, comes back to its starting spot at 2 pi. So these quarter points are very important. That's where all of the key things of that function happen. So if you have these two curves memorized, now what is the sine of 3 pi over 2? Or 270 degrees? What's the sine of that? Look at my sine curve. Go to 3 pi over 2. Where is that on the y-axis?
-1.
Yes. What is the cosine of 0? Sarah?
Sorry.
What's the cosine of 0? Go to 0 on the x-axis and figure out where it's at on the y-axis.
Just B1?
Uh-huh. So, that right on my page, if you were to memorize everything you see on my page, you can create the unit circle in its entirety. Now, the difference between the way I'm recommending you do it and the way the school is recommending you do it is the school wants you to memorize it as a giant pie. Split up into 16 slices. So forth and so on. And they want you to be able to tell them every single angle. In other words, if they say, what is the sine of 150 degrees? Well, that's this point right here. In other words, that's 150 degrees. So you'd need the coordinates on that point right there. And that's one way to memorize the unit circle. For people who can do that, fine. I'm not real good at memorizing 16 things. But I am very good at memorizing stuff that is in groups of 3 or 4. Notice SOHCAHTOA. That's 3 things. My 30-60 triangle only has 3 dimensions. My 45-45 triangle only has 3 dimensions. I only have 3 formulas to concern myself about when I'm interpreting angles that are in the 2nd, 3rd, or 4th quadrant. And finally, all students take calculus. That's 4 things. Between these groups of things that I can memorize, I can tell you the entire unit circle. I may have to figure it out. If you said, well, what is the cosecant of 300 degrees? I'd have to work through a couple of things to figure it out, but I can do it, always. Without having the unit circle, all 16 slices, and all 6 trig functions for each slice, which means 6 times 16. That's 96 things they really want you to memorize. Well, I can give you all 96 things based on the page you're looking at right now.
Yeah. Okay.
Okay? So, do you have some specific stuff that we can maybe work on that involves this?
Well, there aren't really problems. We're just going to be given a worksheet, and we basically just fill out the whole unit circle.
Well, then let me test you.
Okay.
what is the cosine of 240 degrees?
Wait, so when you're filling out the unit circle, it's not going to give you like cosine of a degree, is it? Or like?
Well, it's either in radians or degrees. I can work in either one. If we're in radians, then this is not 180 minus theta, it is pi minus theta. And if we're in radians, this is theta minus pi. And if we're in radians, it's 2 pi minus theta. So, if I said to you, what was the cosine of 4 pi over 3, that's the equivalent of 240 degrees. And I would use this instead of translating back and forth. In other words, whether you're in degrees or radians really doesn't matter. You can always translate everything into degrees, do your math, and then translate it back into radians if that's the way you need to do it. After a while, you kind of get to a point where you can kind of think in radians. It's like a foreign language. In other words, I immediately know that 7 pi over 6 is 210 degrees. 8 pi over 6, or 4 pi over 3, is 240 degrees. So, it doesn't matter whether I give you degrees or radians. What is the cosine of 240 equal to? So, first step is spot its quadrant.
Quadrant 3.
Okay. Second step is find out the equivalent first quadrant angle.
So 240. So 66.
Okay, so it's going to be the same number as the cosine of 60. It may have a different sign, but what is that number based on this triangle?
Square root of 3 over 2?
Cosine is adjacent.
Oh, right. Adjacent over hypotenuse. So 1/2.
Okay. So it's 1/2, but now the last thing to do,
That would be negative.
correct, is this, it's difficult to talk about this because when I say assign a sign, I mean S-I-G-N, and of course with trig you're always talking about S-I-N. So I usually try to say the last step is to put a plus or minus sign onto that number. Okay? So now you can do this same exact procedure with any trig function of any angle as long as it's a multiple of 30, 45, or 60, and it works just as well. Okay? So there's your unit circle in a nutshell. You just memorized it. As long as you can recreate each of these. Now, I said there was 2 ways to figure out your quadrangles. And let's talk about this very briefly. If I draw an angle, well, this is x. This is 1 because it's the unit circle. That's y. And this is theta. So if I said to you, what is the sine of theta? You would say opposite over hypotenuse, well that's y, over 1, which is y. And if I said to you, what is the cosine of theta? You would say the adjacent, x, over the hypotenuse. So we end up with the sine of theta is equal to y, and the cosine of theta is equal to x. So if I had to put coordinates on this point on the unit circle, and this was 30 degrees, Well, the x-coordinate is going to be the cosine of 30 degrees, square root of 3 over 2. The y-coordinate is going to be the sine of 30 degrees, which is 1/2. So, if they insist upon you doing the unit circle with coordinates, like this, that's all it really is cosine of theta is the x-coordinate, the sine of theta is the y-coordinate. Okay? I think they look at it this way at least. In other words, there's no way to escape this. This is a pretty important concept, and that's why it's called the unit circle, and why the hypotenuse is 1 no matter what quadrant you're in, is so that they can say that the sine of theta is equal to the y-coordinate and the cosine of theta is equal to x. Well, let's look at this point right here, where theta is 0. Notice the coordinates of that point. This point right here.
Just 1, 0?
Uh-huh. But that's where theta is 0, right?
Yeah.
So, if I said, what is the cosine of theta? You know that the cosine is the x-coordinate. So this will tell you that the cosine of 0 is 1, and that the sine of 0 is 0.
Okay.
You get up to this point here, where theta is 90 degrees. Well, what are the coordinates of that point?
0, 1.
The cosine of 90 degrees is the x-coordinate, 0. The sine is the y-coordinate, 1.
Okay.
You get over here, the coordinates are -1, 0. Well, the cosine of 180 degrees is -1. In other words, these coordinates at the quadrangle points are the answer to the question, what is the sine or cosine of 90, 180, or 270?
Okay.
If you don't have this graph memorized, this is another way of answering those questions.
Yeah.
Because these two triangles won't help a lot in answering quadrangles. The quadrangles being 90, 180, 270, and 360.
Yeah.
Personally, you need to have these memorized, the sine curve and the cosine curve. So since you need these to be memorized anyway, I actually prefer memorizing the unit circle using these two curves here, as opposed to doing this other technique.
Yeah. Okay.
So, at this point, that's my Trig 101 course.
Yeah. Okay.
Now, you may have some other specific questions about trig other than just that unit circle. If you want to ask them, I'd be happy to answer them. Have they taught you about inverse sine yet?
No, I don't think we have to know that, because all tomorrow is just like filling out the normal unit circle, just like a blank one.
Okay. All right. Let me just make one statement about it, because this will clear it up a lot. We take trig functions of angles and we get numbers. We take inverse trig functions of numbers in order to figure out the angle. This is an if and only if. Sine of 30 degrees is equal to 1/2 if and only if the inverse sine of 1/2 is equal to 30 degrees. That's all I'll say for now about inverse trig functions.
Yeah.
But these are key because a lot of times you're trying to solve for an angle. In other words, if I give you the dimensions 1 and 2 and I say what is theta, well, what you know is that the sine of theta is 1/2. You can see that. Therefore, theta must be 30 degrees. It has to be 30 degrees. And you could get it by putting the inverse sine of 1/2 into your calculator. And it would tell you what theta was.
Okay.
Okay, so that's the thing about, and you will get to inverse functions very quickly. So I wanted to make sure I covered that.
Yeah. Okay.
Okay. All right, Sarah. Good luck with your unit circle.
All right. Thank you.
You're welcome. Talk to you next
Bye.
time. Bye-bye.